Hello and welcome to this month's VuFind video, which is continuing the topic of testing, which was introduced last time around. In the previous video, I showed you how to set up a VuFind test environment and actually run some tests. And this video is going to assume that you have already done that and know how. So this time around, we're actually going to look into writing unit tests. So first of all, a quick reminder on what I mean about a unit test. There are several kinds of tests that we can use in VuFind, and unit tests are designed to test individual units of code. So in theory, every class in VuFind should have a corresponding unit test that confirms that it works correctly. And you might ask, why write tests? There are a few reasons. One is that test-driven development is a very popular way of writing code. In TDD, you write your test first, which specifies the behavior that you expect to see, and then you write and revise your code until the test passes. This is a really good way to get right at the programming portion of the problem and to ensure that all the code you write is doing what you want it to do. Of course, some types of code are better suited to this type of development than others. But certainly if you're writing a new component that does well-defined work, doing it in a test-driven way is a great place to start. And sort of a side effect of this development practice is that your tests become part of the documentation of the code. You know, it's certainly good to write documentation and to include good comments in your code. But if you also have a test case that exercises the code and explains why it's doing that, that helps to add to the understanding of what the code is for and what it's meant to do, which can be really useful when onboarding new developers to the project. And of course, testing is important for some really obvious reasons. We want our code to work correctly. And if we have test coverage, we can make changes with more confidence. So for example, if we want to refactor some code or make something more efficient, if the code we're changing is completely covered in tests, then when we make our changes, if the tests still pass, we can be reasonably confident that we improved the code without breaking anything. Now, while I said in theory, every class in VuFind should have a corresponding test, unfortunately, in reality, that's not the case. Not all of this code has been developed in a test-driven way. And so we actually have some pretty substantial gaps in our unit test coverage. Part of the reason I'm recording this video is that I'm hoping that some of you can help close some of those gaps and that you can be aware of this practice when making new code so that the existing shortcomings of VuFind's test suite don't become larger. So let me start by showing you a useful tool for looking at where we have and do not have coverage of code with tests in VuFind. If you go to VuFind's Jenkins instance, our continuous integration system, and you go into the VuFind project, you'll see that there is an option here that says Open Clover HTML Coverage Report. And this will show us a report of all of the unit test coverage within the project. I should also note that if you ever come here and this link is missing, it probably means that a build is in progress. And you can actually go to one of the completed builds down here to find the link to the report for that particular build. But at this moment in time, there's no build running, so we can just get the latest report through here. And when you look at this report, you can see a lot of red. So, you know, we have more work to do. But the important thing about this report is that it lets us drill down into different parts of the code base. At the top level here, it's split up across VuFind's existing code modules, and we can drill down into namespaces from there. And it reports on 3 types of coverage. It tells us how many lines of code are covered by tests. So if a line of code executes while a test is running, it is considered to be covered. Then there's functions and methods. A function or method is considered to be covered if every line of that function or method is covered. So our line percentage is going to be better than our function and method percentage. And finally, classes and traits. And again, a class or trait is considered to be covered if 100% of its functions and methods are covered. So again, these numbers are going to be even smaller. But let's just pick something that could use a little more coverage, and that will give us an excuse to look at how tests are written and then make some improvements. So I'm going to go into the main VuFind module, which is where most of VuFind's code lives. And as you can see, that's currently about 25% covered. So we have quite a bit of work to do. So when I click into here, I'm now exploring the directory structure of VuFind's code. So there's a source directory inside the VuFind module. I'll click into there. I also need to click into the VuFind directory where the VuFind namespace lives. And now I've gotten to some things that are actually interesting. So here are all of the sub namespaces within the VuFind namespace, and I can drill down into any of those. But rather than go too deep into the code, I'm just going to come down here to the bottom where I notice, we have a number of things that are green that have pretty good coverage, a number of things that are red and have no coverage at all. But we also have this export.php, which has yellow coverage. It's almost there. It just needs a little more work. So I thought this would be a good example to look at today. Maybe we can turn one yellow light green in the process of learning about testing. So when I click through to an actual PHP file, my report looks a little bit different. I have a summary at the top showing all of the methods within the file. And again, these have the same, coverage percentages. And so we can see here that most of the methods are fully covered, but we have a handful that are either not covered at all or are only partially covered. And if we scroll down, we can see that this report gives us all the source code, and it colors in the lines based on whether or not they have test coverage, which is really handy. So this lets us get directly to the place where some work is needed. I should also notice you'll see some yellow lines, and that just means that these are never going to be covered because the code returns here, so it's never going to get to this closing brace, and that's safe to ignore in this particular instance. And also you'll see that there are many lines which are not color-coded at all, and that's because those are non-executable lines of code. Comments don't count for code coverage. Function signatures aren't covered. It's just the contents that matter. So let's start by taking a look at the method that is partially covered, which is this get bulk export type method. And as you can see, we've got one red line in here and two green lines. So that clearly means that what's happening here is that this first if condition is never getting matched in any of the tests, which means that this return is never getting called. So we are going to need to add a test to cover that edge case, and then this whole thing will light up green. And before we do that, let's just step back a moment and talk about what this export PHP file actually is. VuFind has the ability to export data to external bibliographic management systems and to a variety of data formats. And that requires a lot of configuration because there are different ways, different formats need to be exported. And this export class is mostly just a wrapper around all the configuration that allows other code to figure out how to behave when exporting different formats of data. That makes it a pretty good candidate for writing tests on because we have well-defined inputs and outputs that we want to test. So hopefully writing these tests will not be too hard. As you can see, we have a couple of properties in play here, export config and main config. And these are just objects representing some of VuFind's ini configuration files. So main config is config.ini, export config is export.ini, and then all this behavior here is based on what settings are set in those configuration files. All this should be easy to simulate in a test. But before we write any code, let's take a look at the existing test and how that works. So all of VuFind's tests are contained within the modules where the code that the tests operate on live. So we're working now in the VuFind module. So as I've showed in past videos, all of the source code for the VuFind module lives under the source directory, but there's also this parallel tests directory where the tests live. So let's open up the test directory. And in here, there are a few subdirectories. There is a fixtures directory, which is where we store test fixtures or data that is used by some of the tests. We're not going to be looking at that today, but it's good to know that that exists. Then we have integration tests, which we'll be talking about more in the future. And then the unit tests directory, which is where the unit tests live. So we're going to drill down into that. And so inside there, we have sort of a parallel structure to the main source code, but we use the VuFind test namespace instead of the VuFind namespace just to prevent collisions. The test framework doesn't care too much about namespaces, but it's still helpful to use them for that uniqueness. And if I scroll down far enough, here is my export test.php. Now, as I mentioned in last month's video, we use the PHPUnit framework for testing, and this is widely used and well documented. And today's video is not meant to be a replacement for a good tutorial on PHPUnit. I would strongly recommend that you seek one out. But I'm going to show you just enough to get a basic understanding of what we're doing here and hopefully to help you get started. And then other tutorials can build upon that. So every test has to extend PHPUnit framework test case, which is just the base class for test cases in the PHPUnit framework. Any test case class then needs to have public methods whose names begin with the word test. So every function in this class that starts with test is one of the tests that we want to run. And as a general rule, you want to make these pretty granular so that if a test fails, you understand exactly what behavior didn't work correctly. You could just make one big test function and put all your logic in there, but then if something goes wrong, it's going to be harder to figure out what went wrong. And you know, there's some art and some science to this, but as a general rule, I recommend erring on the side of granular tests so that you can identify points of failure. And within each test, the real heart of PHPUnit is making assertions, because the idea is the test is going to try to do something, and then it's going to make assertions about what it expects should have happened. And a lot of these assertions are just, you know, calling a function and asserting that its return value will be equal to something. So for example, in this get bulk options legacy test, we are running the exporter with a particular configuration and saying that when we call this method, it's going to return this array. And so PHPUnit will pass the test if all the assertions are actually matched, and it will fail the test if any of the assertions are not. The framework has a pretty rich variety of assertions that you can make, though much of the time you're going to be asserting equality or asserting that some condition is true. But I highly recommend taking a look at the PHPUnit documentation about assertions just to get a feel for all of the things that you can express in this way. as some of them are quite interesting. In any case, if we scroll back down through this file, we're going to see a whole bunch of tests, all of which contain assertions, because a test with no assertions is completely useless. And then down below all the tests, there are a couple of helper methods. So I have this get fake mark XML that one of the tests uses to create XML records. And I have this get export, which is just a convenient way to create an export object for us to test. As I mentioned when I was talking about the export class, it relies on objects representing configuration files. And so this method just makes it really convenient to pass test configurations into an object without having to instantiate the config objects or do extra work. And if we want to test the default behaviors, the fact that these configuration parameters default to empty arrays means that we can just say get export and we'll get an all default object without having to do any configuration at all. I usually find that when writing a test like this, having some kind of a helper method to construct the subject of your test is really handy. But anyway, now that we've gotten a quick look at what a test class looks like, let's start building on this. So as we looked at before, the get bulk export type method is not fully covered. And if we looked closely in this class, we'd actually see that there is no method explicitly testing get bulk export type. The only reason that we're getting coverage on that method at all is that one of the other methods is calling it, and that coverage is happening as a side effect. So we're just going to want to create a whole new test method that tests all the functionality of get bulk export type, so that we can be confident that that method is behaving the way that it's supposed to. So when writing a test, the first thing to do is to analyze the code and figure out what it's supposed to be doing so that we know what cases really need to be tested. So let's take a quick look at this get bulk export type method again. So essentially, there are three things that can happen here. The first thing that could happen is if the format that we're asking about has a section in export.ini, and that section contains a bulk export type value, we're going to return that value. So this is the most specific case where the export format has a particular value configured for it. If that doesn't happen, the next thing that we're going to do is look in the main config.ini, where we can set a default export type that will be used for everything that's not more specifically defined. So if that value is set, we'll return it. But we use null coalescing here so that if this is unset, we then return the default value of link. So our test should really look at three things. It should confirm that the default value comes back as link if we don't provide any configuration. It should determine that if we ask for a format that doesn't have its own settings, we get whatever the default configuration is. And it should return the appropriate format-specific setting if one is defined. So let's write a test that does all of those things. So I'm just going to go beneath the last test in the file, since I'm adding something new here. And I'm going to put on my comment, test get bulk export type. And all test methods have a void return. The test framework is working off of assertions. It doesn't care what values the functions give it. So we will create public function test get bulk export type, and that will return a void. So how do we want to do this? First of all, let's do the easy part. We should get link as the default if nothing is configured. So we put in a comment to clarify that. And we can just do this directly with an assertion. We're going to say assert equals, and this is, of course, a helper method given to us by the PHPUnit framework that we're inheriting from. And in assertions, you always put the expected value before the calculated value. This is how you ensure that error messages are formatted correctly. So it's always expectation, then calculated value. So in this case, we expect to get link back if we call this method on a configuration-free export object. Then we just need to call the method on a configuration-free export object, which, as I demonstrated earlier, we can say this get export to get that object with no configuration set, and that will call the helper method I showed earlier. And so then on that object we've created, we can just directly call get bulk export type, and we have to give this an export format, and it's fairly widely used convention in tests to use values like foo, bar, and baz when you're putting in an arbitrary value. So I'll just request the export type of foo. So here we're saying if we get an export object with no specific configuration and we ask for a bulk export type, we're going to get link back because that's the default we expect. That simple. And you know, it seems like this is kind of an almost pointless thing to test, but it's important to test every edge case because, you know, say, for example, the code mistakenly assumed that there would always be configuration set. Having this test will confirm that that doesn't throw notices or cause unexpected errors. Always test every edge. So that's our first test and our easiest one. For our other two cases, the default configuration or the format specific configuration, we have to do a little bit more setup work to make that work. So first, as always, I like to start my test cases by putting in a comment about what I'm going to do before I do it. So we're going to say, we should get export specific values from export.ini if set. Otherwise, we should get the default setting from config.ini. So let me set up some configurations that we can use to test this scenario. So first of all, let's create our main config, which should have a bulk export section, which should contain a default type setting. And we'll just set that to download for this example. There are 3 bulk export types that are currently supported, which are link, download, and post. Since link is the default, we can use the other 2 non-default values for our other 2 test cases, which then lets us test everything as elegantly as possible. We could also use fake values here, and that would be equally valid for testing. But in this instance, it just feels right to use real values. So that's what I'm doing. So we've now set a global default bulk export type. Let's also create a format specific one so we can test both of these cases. So the export configuration is keyed by the format identifiers. So let's continue using foo as one of our examples. Let's say that foo has a bulk export type of post. So we've now created these arrays representing the configurations. So we can pass them to our getExport method to get a configured instance of the export object that uses these configurations. So now our object is configured, so we just need to make a couple of assertions. So first of all, we want to assert that if we ask now for the export type of foo, we're going to get post back because that is what we configured in the export configuration. So we can just assert equals post export get bulk export type of foo. And now we need one more assertion to test the default behavior. So for this, we're going to assert equals download if we ask for export get bulk export type of bar. So as I say, foo and bar are popular placeholder values in tests. We configured foo, so we know what that's going to give us. Bar is not configured anywhere, so we expect that to give us the default value of download. And so now, in a few lines of code, we've tested all three of the edge cases that the get bulk export type method could give us. And as I say, this is a place where granularity is debatable. We could really have 3 tests here, each testing one of the edge cases. And then if something failed, it would be really clear which test had failed. But in this case, having 3 entire tests for testing closely related functionality just felt like unnecessary overhead. So I did this as a single test. There's no right or wrong answer. You'll get a feel for it as you work with it more. But anyway, now that I've written this test, why don't we run it and see if it passes. So I'm going to go to the terminal, and I am now in my VuFind directory that I set up last time for a test environment. And as we talked about then, I want to make sure that my environment variables are set correctly. So I created this test environment.sh script in my home directory to do that. I'm just going to source that to be sure that all is set correctly. And then I can use my home directory thing.sh script to run my tests with the PHPUnit fast task. And using the PHPUnit _ extra _ params property to pass an extra value to PHPUnit, in this instance, the file name of the test that we want to run, which we can type out here as VuFind home /module /VuFind /test /unit test /source /VuFind test /export test.php. When I hit enter, PHPUnit runs really quickly, and it tells me that it ran 12 tests with 21 assertions. And just to make ourselves confident that this really did work, let's just temporarily break this test and see what happens. So I'm just going to change this assertion so that it now expects Z-link instead of link. I go back to the terminal and I repeat that test. It now fails. It tells me it expected Z-link, but it got link. It gives me the exact line where the test failed. This is all really useful stuff, and it will help you tremendously if you're using this for test-driven development. So we've done it. We've written our first new test case here. All 3 edge cases are now covered. And it looks like the code is working the way we expected it to work. If I go back to the coverage report, let's see what else needs to be done. So at the bottom here, we have a couple more fairly straightforward methods that are just wrapping around configuration and returning defaults. So for example, get post field is either going to give us the post field defined in the export.ini, or it's going to give us a default of import data. Very similarly, get target window is either going to give us the target window setting from export.ini, or it's going to compose the format name with the word main to get a window name. I will write tests for these, but I'm not going to make you watch me do it because this is extremely similar to what we just did. However, there's also one more uncovered method that's significantly more complicated to cover. And so let's take a closer look at that one. And that is this get bulk URL method. And this is more complicated because this method interacts with another object. In this instance, it's accepting a PHP renderer object from the MVC view layer of the Laminas framework, and it's using some of the helpers in that object to do work. Specifically, it's relying on the URL helper to call the Laminas router, and it's relying on the server URL helper to figure out an absolute URL. And as I mentioned, unit testing is about testing one unit of code, the export class. It is not our job in this test to test the URL helper, the server URL helper, and the PHP renderer. We really don't care about those things except to the extent that they expose an interface that this class depends upon. And so it is in cases like this where we need to use mock objects. Mock objects are a useful testing concept where you create a fake object that has predefined behaviors which stands in for a real object during a test and allows you to simulate interactions. Fortunately, PHPUnit comes with built-in, quite rich support for object mocking. And so you can use that when you run into a situation like this to test behaviors without having to bring in and construct lots of external objects and dependencies. Obviously, there's also a need to test that real interactions really work, but that's what integration testing is for. We'll talk about that later. When we're unit testing, we generally don't want to go down that road, and mocks are preferable. As with everything, there may be exceptions where it actually makes sense to bring in another class, but that is the exception rather than the rule. And you should think about mocking first when you run into something like this. So let's analyze this code a little bit before we start writing, just to see exactly what it's doing. So this is taking the view object, that PHP renderer. It's taking the name of a format, and it's taking an array of IDs. And what this method is used for is constructing a URL that can be used to export multiple records in a single batch. So this is used by the bulk export functionality. So we just need to test that this constructs an appropriate URL for the input variables. And we don't really need to care too much about the internals of any of these helpers that it's using. So what are we doing? We're creating an F parameter that has the export format. We're creating an array of I parameters that contain all of the record IDs. We're looking up the cart do export route, which is going to do the actual work. We're making an absolute URL out of that. So we're first using the URL helper to turn this route name into a path. And then we're using the server URL helper to turn that path into a full URL. And then we're appending some parameters onto that base URL based on this array we constructed up here. Then, depending on whether or not the format we're using needs to be redirected to or can be directly accessed, we're either using the get redirect URL helper method, or we're returning the URL in an unmodified form. So there are really kind of two paths we want to test here: the needs redirect path and the does not need redirect path. And in the interest of keeping this video short, I'm just going to test the default behavior. I'll do the rest of the work subsequently. So this is pretty straightforward. We're just checking that a few things get plugged into a URL. It only gets complicated because of the use of this helper code and the need for mocking. So let me show you how that works. As before, we are going to want to create a new test method, which I'll put below the existing test methods. We'll just say test get bulk URL method returns void public function test get bulk URL void. All right. So When you're doing mocking, you sometimes have to kind of build things in an inside-out way, because what we have in this code is two different helper objects that are being retrieved from a container object. There are a variety of ways we could approach this. I'm just going to do this the most brute force way possible, make two fake helpers that do fake work and a fake container that returns the fake helpers. So I have to build the helpers first so that I can then put them inside the container. So first of all, let's just create our URL helper. And the way that you do this is there is a method that you inherit from the base test case class called getMockBuilder, which gives you an object that can build mocks. So I say this getMockBuilder, and then I pass it the class name of the class that I want to mock. In this case, it's going to be Laminas view helper URL, which is the view helper, the URL view helper class. Then it's usually a good idea to call disable original constructor, which just tells the mock builder to build the mock without calling the real constructor of the real object, which you rarely want to do when you're mocking. And then I say get mock, and that's it. That's going to give me a mock URL object, which has the interface of the URL view helper, but doesn't actually do anything. So there won't be any unexpected side effects of the test. Now, when you're building mocks, one of the most important things is to set up some expectations on those mocks. As I said, making assertions is the key to successful tests. And when you're building mock objects, you actually set up their assertions about what they are going to do or how they are going to be used, which is how you verify that your test is behaving correctly. So in the case of this particular object, we're just expecting the object to get invoked so that it can look up a route. And that's going to use the magic method __ invoke. So let me show you what this looks like. To set up an expectation, you just call the expect method on the mock object. So I'm going to say URL expects. And the expect method expects a parameter about the frequency or type of access of the method that you're going to be expecting. So in this instance, I expect my code to call this method once and only once. So I can say this once, which is a helper method that tells us expect one call. There are some other things you can do here. So for example, I could say this any, which means that it expects 0 or more calls to the method. It's really flexible, but not very specific. I could also say this exactly one, which means that this will be called exactly once. It's the same as saying this once, just less concise. So I'm going to put this back. We expect this method to be called once. Now we actually need to tell it what method we're expecting. So we arrow to method __ invoke. Now we need to tell the method how it's going to be called. And the very nice with method is useful for this. With allows you to make assertions about all the parameters of the method that you're expecting. So in this case, we expect invoke to be called with the name of a route, cart-do export. So I can just say this equal to cart-do export. So we're now expecting that the method will be called with the parameter cart-do export. And if my invoke method had multiple parameters, I could put a whole series of assertions here, one for each parameter. But in this case, there's only one, so I'm done. And finally, I can close by saying what I want my mock object to do when this method is called. In this case, I want it to return a value. which I'm going to say is /cart/VuExport. So this is going to simulate what the real Vue helper does. It takes a route name and it returns a path. But it's going to do that without actually using any of that code, because we don't want to be distracted by the internals of that Vue helper. It should have its own test. That's somebody else's concern. We just want to plug in some behavior to test the subject of our test, the export class. Now, this whole mocking syntax can take some getting used to. It uses what's called a fluent interface, where methods return objects which expose additional methods. It doesn't necessarily look like a lot of PHP code that you've written, but it reads really nicely, because I can actually say URL expects once method invoke with the value equal to cart do export will return the value cart do export. So this is actually quite readable in terms of expressing what the test is doing. So that's, in any case, one method down. But now we need to mock the other helper, which is server URL. And again, we're going to follow a very similar pattern here. This get mock builder, laminas, Vue helper, server URL class, disable original constructor, get mock. And again, we need to set up our expectations for the server URL helper. This expects once the invoke method with, and in this case, we're going to expect the input of the server URL helper to be the output of the URL helper. So we expect this to be equal to /cart/do export, because that is what the URL helper was defined to return up above. And we will say this will return a value of http://localhost/cart/do export. And again, this is all fake, but it's simulating what the real Vue helper would do, which is take in a path and prepend a full host name to it. So we're getting there. But we now have our helpers only. We need to also simulate the PHP renderer container that the code is pulling these plugins out of. So again, it's a very similar pattern. Vue equals this get mock builder. This time we're going to be mocking laminas Vue renderer PHP renderer. And of course, we know this part by looking at the type hints in the function that we're testing, which specified that the Vue object was one of these PHP renderers. That's how you can sort of get into this. And then, of course, if we weren't already familiar with how the PHP renderer works, we might have to look at that code and get a better understanding of it in order to mock it correctly. But in this instance, I know how it works. And so I don't want to go too deep into those weeds. But anyway, for mocking this, we want to disable the original constructor, as with all the others, and then get the mock object. Now, the behavior we want to mock here is a little bit more complicated than the behavior that we are mocking for the individual plugins, because in this instance, the same method is getting called twice with different parameters and returning different values. Because first, the plugin method is called to get the URL, rather the server URL helper, and then it's called again to get the URL helper. Fortunately, the framework gives us some helper methods that make this quite easy to do. So we're going to say Vue expects, and this time we're going to use that exactly specifier I mentioned earlier. We expect exactly 2 calls to the method plugin, because 2 plugins are going to get pulled out of here by the calling code. And since we're going to have different things happening, instead of using with and will, we use a different pair of methods. First, we're going to say with consecutive, which allows us to specify an array of parameters for a series of calls. So our first call we expect is going to be server URL, and our second call is going to be just plain URL. So now we've defined two inputs. Then we can use will return on consecutive calls to define multiple return values. So on the first call, we want to get back the server URL mock that we defined above. And on the second, we want to get back the URL mock. And that's it. We've set up our entire mock test environment. We've created two mock view helpers that do very specific things, and we've put them inside a mock container that expects a very specific thing. Of course, this isn't entirely ideal because this test is actually capturing some details that don't matter from an implementation perspective. For example, the order in which the two plugins are pulled from the container doesn't impact the functionality of the code. If we reversed the order in which the plugins were retrieved, we would break this test, even though it wouldn't impact the functionality. That's not ideal, but in the instance, in the interest of convenience, we live with some of these suboptimal things. But it's the kind of thing you might want to keep in mind during your test design. Can we make this more general? But this is a really good way to demonstrate mocks, so I'm doing it this way. So with all of that done, we now just need to make an assertion. So what I'm going to do is I'm going to assert that I'm going to get some kind of a URL. I'll figure out what that URL is going to be as I work through it all. So for this test, I'm just going to test the default configuration. I'm not going to worry about passing in special configuration yet. I would want to do that later to test that other case I talked about based on whether or not we're working with a redirecting URL. But for this test, we'll just test the default behavior. So I can directly call get bulk URL on a default export object retrieved from the get export helper. I need to pass it as the first parameter, my mock view object. Then the second parameter is the name of the export method. I'm just going to use that placeholder of foo. And the third parameter is an array of identifiers. I'm just going to arbitrarily give that 1, 2, 3. So I happen to know what I should expect here. So first of all, because of the way I set up my mocks, I know that the URL I get is going to start with localhost/cart/do export because I've set up my mock server URL method to return that. And I'm also testing through my other mocks that this particular route is being requested of the URL helper and so forth. But if I get a URL starting with localhost/cart/do export out of my get bulk URL call, I can be quite confident that my mocks were used correctly and that all of these assertions were met. If anything was wrong along the way, the test would have failed before reaching this point. I also know, based on reviewing the code earlier, that I'm going to get an f equals foo parameter on here because I passed in an export method of foo. The code is adding that. And then I'm also going to get 3 IDs added onto here. And they're going to be a little ugly because they're URL encoded. But that's going to look like I%5B, %5D for those URL encoded brackets. I'm going to have 1 and 2 and 3. And that's it. If I've typed all of this correctly, I am setting up some mocks, I'm making an assertion, my test should pass. Let's see if I did it correctly. So if I go back to the terminal, I can see that when my test passed earlier, I had 12 tests and 21 assertions. I should now expect if I run my tests and they pass, that these numbers will go up. I should have 13 tests and significantly more assertions because all of those setups in my mocks are making more assertions. Let's see what we get. We get a test failure because I made a typo. So let me go back and fix that. By habit, I typed HTTPS here, when in fact, I'm returning HTTP here. And I'll just pretend that I did that as an exercise. So now if I run the test again, this time it passes. As I predicted, I have 13 tests, more assertions. We're up to 25 now. And so that's a lot of the basics of what you need to see to understand unit testing. If you can make assertions and you can mock objects, you're well on your way to writing all kinds of useful tests. But let's not just end there, because I happened to notice while I was writing these tests that some of the code in the export class is not quite as efficient as it could be. So let's benefit from these tests by optimizing the code and then using the tests to confirm that we didn't break anything. So let me show you the couple of things that I noticed. First of all, in get bulk URL, we create an empty params array, and then we append a value to it. There's no reason to do this in 2 steps. We could just initialize the array with the value, and then we've trimmed off a whole line of code that we didn't need to have. Similarly, down here, when we were looking at get bulk export type, this entire if statement is really not necessary because now that we have the lovely null coalescing operator, we don't need to do all these is set checks anymore. We can reduce this entire function to a single return statement with no ifs at all. So I'll just consolidate these comments and then I can change this to just return the format specific type if it's defined. Otherwise, null coalesce to the global default type. Otherwise, null coalesce to the default of link. We've just changed together the options in order of priority. Much more readable code once you understand null coalescing. We got rid of several lines of unnecessary code. So now I just run my tests and they should still pass. And they do. So I've just refactored with confidence. And that's all I have for now. Next time, we will look at some integration testing. In the meantime, as I said, I really encourage you to read a little more about PHPUnit. Maybe consider trying to expand VuFind's tests. I'd love to get some pull requests, adding new tests. And if you have any questions or problems along the way, just reach out to the usual support channels and someone will help you out. Happy testing. Talk to you next time.